Hey guys, welcome to the channel. In this video, I will be explaining to you how data centers work, because we've been seeing so much stuff about data centers. They're using so much water, they're using so much expensive GPUs, they're taking up so much electricity. So what's all this fuss about? Okay, so for that, there's two types of data centers, right? There's the conventional data center, and there's these new AI data centers that are being built. But to understand what the new AI data centers have, we have to first understand what a data center is and what kinds of different technologies are in that data center to actually make it function, right? So let's understand that first. So data center is basically a physical location that stores computing machines, okay? Stores computing machines and their hardware related equipment, right? So it basically has three main things. There's compute, storage, and network. So how do all three of these link together? So storage is basically, think of it as, let's say you are a government and you have videos coming in from all traffic signals of video footage of cars coming into the traffic signal and leaving from the traffic signal. Now you want to detect which cars are obeying the laws, which cars are not obeying the laws, okay? So what you do is you take all that footage and you stream that footage to some data center. You stream it to some data center. You just send it over there. And once the footage is there on that data center, that is storage. The data center stores that footage for the time being. It stores that footage. Then you want to identify if somebody's breaking laws. But to do that, you need to first know what is the nameplate of the person that's breaking laws. So you need to identify the driver's nameplates. So how do you do that? You get a frame from the video that you just stored, the storage part from that data center, and then you send that video frame into, let's say, I'm broadly speaking here, you could send that video frame into a neural network. And that neural network identifies where a number plate is. Okay, so it returns the bounding boxes of that number plate. So if the number plate is located within this rectangle of this whole image, then it returns the coordinates of that rectangle. Now you take the coordinates of that rectangle and maybe you send it to another neural network that identifies what is the text inside that piece, or inside that subset of the image. Okay, so in both of these tasks, what happened? You tried to compute something. You tried to send your data to a neural network, and the neural network was pre-trained, so it made mathematical computations to get to that final output of the neural network, which is the coordinates and then the text. So this whole thing required mathematical computation through the neural network, right? And that is what you can say broadly compute is about. It's about computing stuff, right? Mathematical computations. And network is basically how is your data center connecting to edge devices? How is your data center connecting to the video capture, the cameras that are installed at that traffic checkpoint? Okay, so that's network. How is the connection being established? So these are the three main parts of a data center, because if you don't have network, what's the point of that data center, right? If nobody can access what's on the file remotely or maybe on that premise, then it's of no use, right? So all these three things are, they're important. They're important for the data center. Now, there's two types. Well, not exactly two types, but this is like a broad, like some general examples. Okay, so computing resources. So the resources that you use to make that computation. You have a lot of different types of RAM, a lot of different types of storage. Some have SSD, some have, hard disks, like the rotating hard disks, and the SSDs purely. So you have all of these different features and different resources and how do you use them. So there's two types, broadly two types. So there's rack servers and then there's blade servers. Okay, so let me show you what a rack server looks like. Hold on, rack server, right? So look at this. It's basically a rack. Okay, it's basically a rack, and you store all these servers inside these racks, and then you can just slide the racks out and then upgrade it, change some information. So yeah, you basically store that in racks, and this is a much more detailed kind of thing. Okay, and that's a rack server. Now, in general, rack servers are, in terms of performance, worse than blade servers, because a blade server, it's like a modular kind of device. I'll show you in a second. It's called like a chassis on which you stack all the components. Not exactly stack, but it has place for you to place all those compute resources, and yeah, it requires a smaller area and a lower power consumption, higher processing speed. So the blade server kind of looks like this. Yeah, so this is like kind of one blade server, and then you stack all of these together like this here. These require much less spaces. So yeah, this is one blade server. So you see this guy is taking it out here over here. And then yeah, this is one blade server, and you can see like there's a lot of different elements that have been put over here. Okay, so there's broadly those are the two types. Where to go? The article. Where's the article? What? Okay, here. Yeah, here it is. Yeah, and now there's basically, you know, the storage devices. You have file storage, which is like videos, images, block storage. Yeah, they didn't really specify that here, but you can read this up in your own time. But the interesting part over here is the support infrastructure and the network infrastructure. So the network infrastructure, the way that it works is you have cables, switches, routers, or routers, however you call it, and they connect all of these data center components together. So data movement and connectivity across the system. So yeah, that is your network infrastructure. And then your support infrastructure is basically power. Are you getting enough power to maintain to ensure that your data center is actually running all the time? Because you want minimal downtime, right? And then the downtime also affects what tier your data center is going to fall in, which we'll see later in this article. All right. So yeah, you have all these cooling equipments, fire suppression systems, building security systems. So that is a support infrastructure that enables you to use that data center. And then there's basically like 4 tiers of data center. Okay, so most of these tiers, they're differentiated. The main differentiator between them is quality, performance, cooling infrastructure, basically all the support infrastructure, and downtime. Okay, so downtime, tier 1 has 29 hours of downtime, tier 2 has 22 hours, tier 3 has 1.6 hours, tier 4 has 26 minutes every single year. Okay, so this is very less downtime. It's pretty good. There's on-premise data centers, basically banks. Banks use a lot of these on-premise data centers because, you know, if you use a cloud to store like account details or transactional history, yeah, and it gets hacked, then you're in trouble, right? But if it's on-premise, then you can easily access it, and there's minimal latency, and you can implement your own network security systems, which you might not be able to implement in a cloud infrastructure. Okay, and you know, the security infrastructure isn't just limited to software. There's human resources like security guards outside, and there's a bunch of things that are not software that contribute to security. right? So that's why you might prefer on-premise data centers. But if you're like a startup, right, you're going to use cloud. If you're a startup, you're just going to use cloud. You use AWS or Azure or whatever you like based on your ecosystem. Azure is mostly used for like people that are operating within the Microsoft ecosystem, like SQL Server. If you're working on Power BI, yeah, Power BI, SQL Server. What else is there? Yeah, but mainly that. Most of the tech industry, like banks, they operate in the Microsoft ecosystem. So that is pretty useful. And then there's co-location data centers. So basically these data centers are like they're like large data center facilities, okay? And they allow you to lease that land, which you can use to install your data center. And then you use that land and that data center, and then you rent that data center out to somebody else, like what cloud does. All right. Yeah. So I know it's a little confusing, but um, yeah, there's a slight difference in them. So you kind of lease this from a bigger contractor, and then a cloud data center, you rent both the space and both the infrastructure. But here, you rent like the space. All right. And then how does AWS manage its data centers? So this is the AWS article. So I thought it would apply to Microsoft as well. Is in general, it's a general article, right? So there's like the perimeter layer, which got your security guards. It's got your fencing, security feeds, intrusion detection technology. So if someone's coming in, if someone's wearing a hoodie coming in, it's going to detect that instantly. Oh man, why is this guy wearing a hoodie? And why is he not showing his face? Why is he trying to come into this door? Right? And why is he coming in the night? So you can have like intrusion detection technology. And then you have like the infrastructure layer. So can you secure that your data center is up and running? So you have water, transmission, power, cooling systems, because if it gets too hot, then it might damage the equipment. Fire suppression, if there's accidentally a fire, how fast can you suppress stuff? And then there's the data layer. So are you able to identify the data packets that are coming in, going out of your data center, and identify that? Which might be malicious, which might be not malicious, and which might be trying to put like maybe a virus into your data center and steal information, look at data that they're not supposed to look at. So that's the data layer security. And then environmental layer, right? If there's a tsunami coming to your data center, then you might want to enable processes that relocate all of your data to another data center somewhere else, right? So you want to be able to detect tsunamis. You want to be able to like detect maybe storms, tornadoes. I guess a lot of that in America. So, and that is pretty important. Now that was data centers in general. Now, how do AI data centers work? Where's my article? Yeah. I'll link all of these articles in the description, and if you're interested, go have a look at them. They're pretty amazing, okay? So now AI data centers, they have like one main difference. Traditional data centers use a lot of CPUs, right? Central processing units, but AI data centers use a lot of GPU for compute, right? Graphical processing units, and most of these are from NVIDIA, and they use like this NVIDIA H100 GPU. Yeah, so the video got cut off there, but they use basically these H100 GPUs, and if you look at these, pretty expensive, okay, pretty expensive. 260K, I mean, what the hell is this? Who's gonna buy that? But apparently people do buy that, all right? So 31K, it's super expensive. Now, what happens when you got this many GPUs working all time, overtime on that data center? Okay, so it generates a lot of heat, and then you need cooling. So how do you cool? Well, you make a cooling system. Where's my article? Here it is. Yeah. And so there's basically like ventilation cooling. This is more used in like traditional data centers, cold aisle and hot aisle cooling. So let me tell you about cold aisle cooling. So basically, here is the server rack, and this generates heat. And the heat goes from this side, and then the ventilator or this crack unit, it's this is basically computer room air conditioner unit, crack unit. And then this takes in the hot air, okay? And then it sends that hot air down and cools it down. And then it through, in like between over here, below this, and then through here, it cools down the servers, right? And so the heat is produced out here, and then there's cold here, so then that balances the temperature, that regulates the temperature of the server racks. And this was cold aisle cooling. And the hot ceiling, the hot aisle, this was the cold aisle containment, and this is the hot aisle containment. So basically the way the hot aisle containment worked is the reverse. So the heat is generated over here, and then this heat goes into this crack unit, and then the crack unit releases cold air from the outside, okay, from the other side of the rack. Here it was from the between, here it is from the outside. So that is a good difference in them. And then this is a really interesting picture. I didn't bother to understand this because what the hell is this? I'm not I'm not a mechanical major. I'm a computer science major, so I'm not gonna read that. But liquid cooling is much cleaner, as you can see over here. Okay, liquid cooling. Did I say cooling or cleaning? I think I said cooling. Okay. So basically, you put a coolant in these pipes, okay, in these lines. And then these lines connect over here inside the GPU. And then it takes the heat from this GPU and it dissipates it using this coolant all the way over here to the liquid lines, and it is much more efficient. But because of this, there's a lot of water being used. There's a lot of debate right now around how much water these data centers are consuming. Because if you look at the news, I think it was in Texas, I don't know, Ohio or something, where residents are facing more electricity bills because of data centers. Yeah, where was it? I remember reading something about it. I don't remember the exact location, but somewhere like the bill increased by like 70%. Okay, and there's apparently some protests going on about that. Pennsylvania? No. But yeah, there's a lot of debate around this because these use up a lot of water. Because look at this. I don't know, this might be a representational image, but I guess, yeah. Liquid cooling, yeah. Look at this. The same diagram that we saw before. But so you see, it is it's a big debate that is going on. Either we stop AI, and this AI are not making, a lot of money anyway. ChatGPT, Gemini. I think only Claude right now is profitable. Is Claude profitable? OpenAI is losing a lot of money. So profit. So the revenue, where's the profit? Tell me the profit. Tell me. How much profit is it doing? Yeah, so I mean it is pretty profitable, right? Claude. And I think Claude should be profitable. But yeah, guys, that was my video on data centers. So if you like this video, please subscribe to the channel. It will really help me out. Like the video. And tell me in the comments, What do you think about this AI using a lot of water? Share me your thoughts, and thanks for watching. I'll see you later. Bye.